mưa lạnh. As I wrote on the chat in the chat box, that the best way to understand a topic is to prepare a list of questions which you are not able to understand. If you are able to understand, perfectly fine. If there is even a little bit of doubt, it is better to get clarity on that. Since this course has been on connecting thermodynamics at a macro level to the micro level, a link between the macro state to micro state. Therefore, it is very, very important to understand the concepts involved into it. When we were talking about bulk properties in chemical thermodynamics, there the measurements of thermodynamic properties were mostly in terms of calorimetry. Although spectroscopy could also be used, but that spectroscopy usually was UV visible spectroscopy, fluorescence spectroscopy. Their signatures, changes in signatures, could lead to understanding of thermodynamics. The enthalpy which is derived from such spectroscopic methods is called Van 't Hoff enthalpy because that is obtained based upon Van 't Hoff equation. In statistical thermodynamics, we started talking about individual molecules, individual atoms, individual particles, and their energy levels, energy states, their degeneracies. So that means we started connecting something which was called molecular partition function, which was a measure of how many thermally accessible states are there. So there is one question from Nivid Chandra. Since statistical mechanics came well before quantum mechanics, so how was it used when data from rotational and vibrational spectroscopy were not available? Well, the evolution of any science happens over a period of time. Even when we talk about the chemical thermodynamics, when you go back several years ago, let's say, when I talk about measurements in chemical thermodynamics, means the calorimeters. If you go back, the origin of calorimetry, origin of thermochemistry, the calorimeters were almost of the size of the room. And initial few experiments were done on animals because if you pass on oxygen, the oxygen will be consumed by animals. They will produce carbon dioxide, and then you determine carbon dioxide and then do some calculations and find out the thermodynamic quantities involved. But over a period of time, there have been developments, and with the developments, today we are able to measure heats down to the order of microjoules, microcalories. So similarly, over a period of time, statistical mechanics has undergone the improvements. And obviously, when you have seen that while calculating or while determining the rotational and electronic or vibrational partition functions, a knowledge of rotational energy levels and vibrational energy levels became necessary. And thus, over a period of time, the theories have improved. We have started getting better results. And today, we are able to apply statistical thermodynamics in addressing a wide range of problems. So continuing with what I have been talking on connecting individual molecular properties, individual particles properties with the bulk properties. That is where the statistical and chemical thermodynamics came we started bridging them. One very important thing to understand when you are talking of thermodynamic principles. Thermodynamics is a branch of science and technology which is required by everyone. So why I am making this kind of blanket statement is because we are interested in the processes which should happen easily, whether it is chemical, pharmaceutical, biological, any processes. And spontaneity is connected with the change in Gibbs free energy. Or you can also connect spontaneity with many other thermodynamic quantities. Therefore, finding out ways, one is experimental, other is theoretical. And both are very powerful methods. If the experimental and theoretical match is there, wonderful. Statistical thermodynamics does not mean that you don't need experimental measurements. You still need experimental measurements, because how do you get the information on energy levels? You have to know the principle of, and also get the information from rotational spectroscopy, vibrational spectroscopy, and also electronic spectroscopy. So therefore, when I talk about statistical thermodynamics, there you are not using calorimetry, because calorimeters give you direct determination of thermodynamic quantities, whereas the spectroscopic measurements give you Van-Hoff analysis, give you thermodynamic quantities based on Van-Hoff analysis. But when you talk about statistical thermodynamics, where you start subdividing the ensembles into NVT, NVE, or mu VT based, and then you set your system accordingly, where, for example, when you say NVT, you are keeping temperature constant, you are allowing the energy to exchange. If you are keeping NVE, microcanonical ensemble, in that case, you are not allowing the temperature to remain constant, you're keeping the energy constant. So therefore, depending upon your requirement, you choose a system and then you get the thermodynamic quantities. I'm glad, Nivid, that you have asked a question. And if there are more questions which are based upon our course, definitely, even if you want any question based on chemical thermodynamics, and if you have some doubt about how it can be connected with statistical thermodynamics, I will be glad to answer that. So I'm sure that with time, there will be more questions. As a student, in addition to the derivations for various formulae in statistical thermodynamics, I would be very much curious to solve variety of numerical problems, because it is not just mugging up the formulae, but when you are substituting the values, unless you practice yourself, you will not master on what value to put, what unit to put, etc., etc. For example, in the calculation of thermal wavelength, where the m, which comes in the denominator, that is the mass of one particle. Usually, if we are careless, we will just put mass of 1 mole. So that is why I said that if I were a student of, or I am a student of statistical thermodynamics, I will make sure that I use the derived formulae in their application in solving variety of numerical problems. The course that I have covered is basically, as the title suggested, it is fundamentals of statistical thermodynamics. So It's not that, we have done everything. We have only covered the fundamentals, and most of the equations that we derived were applicable to ideal systems, ideal gases. But towards the end, we started discussing or bringing little bit non-ideality when we started talking about virial coefficients. Later on, slightly we touched upon the condensed phase, where we further started talking about the radial distribution functions. But I would say that if your fundamentals are strong, then you can always address the statistical thermodynamics at advanced level. So those who are more interested in using statistical thermodynamics in the problems of their interest, I would suggest that after having gone through this course, you should also take some of the electives which are offered on statistical thermodynamics. That will definitely help a lot. So Nivid, you have asked which NPTEL course can be taken as elective at advanced level for chemistry. And I am sure that your question is which NPTEL course on statistical thermodynamics, because there are several elective courses which may be available. The exact course, which one is available, I will have to check on that. But one thing is sure, that even on fundamentals of statistical thermodynamics, there are not many courses which are available on NPTEL or this MOOCs platform. There are certain only a few more courses on NPTEL based courses are available. I think one is from a faculty from IIT Guwahati, one from IIT Kanpur, and maybe one from IIT Madras. These three are, I'm sure that these three I'm sure of. But the advanced level elective on statistical mechanics, I will only check, and then you can, always contact me on my email, and I will be glad to give you an answer. That mute, unmute, that thing. Okay. It looks like there is no one else on the platform, but I'm sure the candidates may be busy with some other commitments. But if you have any question anytime, you can always write on this platform or you can write on my personal email ID at my departmental email ID, which is available on my website. And if you want to have another live session, do let us know. We will organize another live session. But once again, if there is any doubt, any query, please feel free to write to us. Thank you.